Hi, in this video, we are going to talk about Koalas, which is a distributed data frame API that can run on top of Spark. Now, today, Python is a de facto language for many data and analytics workload. There are rich libraries in Python like Pandas, NumPy, SciPy, which makes your data analysis, machine learning, and statistical analysis pretty easy. The main challenge though with pandas and Python libraries is it is very memory dependent. It cannot run in a distributed way and it has to depend on a single node system where you load the data into memory and process it. So it is not ideal for very large data set. While there is a way to make pandas more efficient by chunking the data and everything, still there is a limit in which it can enable processing. After one stage, it is still going to fail or it's going to take long time to process your data. Now that's where a lot of distributed framework came into existence. One is Dask API, which runs Pandas in a more distributed way. It is very similar to Pandas like API, right? Then also Rapids released an QDF, which is a CUDA data frame, and CUDA data frame runs on top of GPUs, and it has pretty similar resemblance to Pandas API. Now, on the other end, Spark is a very efficient processing engine for running a very pretty large data set. But the challenge is somebody who is very comfortable with pandas and everything, there's a huge learning curve to learn Spark. How can this be made simpler? And that's where Koalas come into play. So the idea of Koalas framework is basically it resembles your Pandas API as it is. So basically, if you're compatible with Pandas, if you're working on a single node system, you can just get up and running onto a Spark in no time. So Koalas makes the learning curve significantly easier by resembling Pandas API. That's what it does, and it runs on top of PySpark. Now that is one part of it. The second part is now today data scientists who are basically pretty familiar with pandas, they can get started quickly. But there are a lot of existing projects that are running in pandas, and over the time the data has grown to a limit that it can still not fit into a single node memory, and you need a distributed processing system. So when you're converting that project from pandas to PySpark in an old way, you have to rewrite the code to fit into Spark data frame syntaxes. But with this package with Koalas, basically you are simplifying the entire process. You can see how easy it is to move your job from pandas to Koalas. The syntax is exactly same. So let's get started with the code. I'm going to use the Databricks engine to demo this. So first thing what I'm going to do is I'm going to use the loan data set, which is nothing but the lending club data set that is available on Kaggle. Now I have just taken that and I have just gone to data and say like add data and then uploaded the file, and it's already like available over in this window, right? So this is the loan data set that is available in a distributed file system, that is Databricks distributed file system. Now first I'm going to show pandas and then convert it into koalas, right? So now for pandas to work, basically the data should be in a local file system rather than a distributed file system. So what I'm doing is in the first line, I'm just doing a file system copy. I am moving the Databricks file system, the data in the Databricks file system into the local file system. Now, for this video, I'm going to show more on the functionality of the framework. So you need not understand complete data, but wherever it's required, I will tell you what the data is about, right? So that's what I'm going to do. I'm going to import two libraries. One is the Pandas libraries, and second is the Koalas libraries. The Koalas libraries is basically in the Databricks.koalas package, but this package does not come with Databricks. So to install the package, what you need to do is you need to go to the cluster tab and go to the active cluster that you are running in. So click on the cluster, and once you click on the cluster, there will be a libraries tab. Click on the libraries tab and then click on install new. I have already installed it, but I'm going to show you. Click on the libraries tab and then click on PyPy, which is the Python repository for installing the packages. You do a install and comes from there, and here select Koalas and then say install. So it will get installed to your cluster and you can start using it. Now let me go back to the notebook. So these are the two libraries I'm going to import. And what I'm going to do is, first thing is I'm going to use pandas. So I'm using that pandas as PD. I'm doing a pandas.read CSV. and then I am loading the file that is in the local file system. As I said, Pandas cannot work with distributed file system, so I have moved the data to local file system, and I'm just quickly going to run it. I'm not going to talk more about Pandas, just one or two syntaxes and show how easy it is to use Koalas with the same syntax. Then I'm just printing the first 5 record of the Pandas data frame, and I'm doing value count over here of that loan status column. So loan status column is basically the target column that says whether the customer is defaulted, customer account is current, or it is running 30 days past due, 60 days past due. So it will just give me that how many records are there in each bucket, each target bucket. That's what it's telling me. Now this is Pandas, right? Now for me to run this in Koalas, the only thing I need to do is, what I have done is I have imported the databricks.koalas package as KS. I'm just going to replace this PD with KS, right? And then, as I said, the syntax are pretty similar, so there is no learning curve at all. And then I'm going to, rather, I can still use a local file system, but for efficient processing, I'll just convert it to a distributed file system package, that is the Databricks DBFS, that is a Databricks distributed file system. It is very similar to a HDFS or Amazon S3 bucket, right? So that's the only change I have made. Now let me run this. And yeah, now you can see basically the engine has changed from your local engine. That was the case previous. Now it's running a Spark job. You can see it has created various Spark stages, right? And so it has with the same syntax, rather than running it in the local mode, it's running in a more distributed mode. Let me run the same command. Let me select the first 5 records, and then I'm sorry, just select the first 5 records. So you can see basically it's running in a more distributed way. The data set that I am selecting over here is not pretty large. So you may see like Pandas slightly faster, but the idea is when your data set is pretty large that it cannot fit into a single system, Koalas will be very fast and very efficient because it is running in a more chunking your data and running in a more distributed way. All right, so now you can see the output of the Spark job, and the same command, the value counts. Basically, if you see the regular Spark data frame, there is no function called value counts, but it is just replicating the Pandas data frame. So you can still run the Pandas function value count and get the target value, and you can see basically the target value is similar, right? That is one part of it. Now I'm going to show more functions which resembles Pandas, and also there are some unique functions that are available in Koalas that are pretty good, that can even further simplify your data analysis and data analytics journey. So let me get started. What I'm doing is I'm just setting option over here. This does not do anything. So if I don't set this, if I have 1,000 rows, it's going to show all the 1,000 rows up to 1,000 rows. So I'm just limiting the number of rows to show outside to 50. So that's what I'm doing over here. Now, this particular, if you see this particular data set has a lot of columns. So I don't want to take all the columns and run it. So I'm going to limit the number of columns that I want to that I want to show it to you. So what I'm doing is, I'm from the loan data frame that we created, which is a Koalas data frame. I am selecting a few columns, that is the loan amount, grade, term, and loan status. Loan status is the target column in this case. And if you see, this is the same selection method that we can use in Pandas as well. So we are just using the loan data. We are creating a list of columns that you want to pick up from that, and then I am assigning it to an LD underscore select data frame, and it is assigned now. Now if I go and again, I'm just going to run the value counts for now again, just to see if the LD select column is loaded, and you can see basically you have the same value count. So now we have a data frame, again a Koalas data frame with very selected columns. All right, now what I'm going to do is I'm going to run a group by. So in Pandas, we do a group by function similar to this and do a AGG function. That's the same function I am running over here. So I'm telling this data frame group by the grade column. So grade is the one column I have selected. What is grade is, whenever you apply for a loan in Lending Club, they grade your account. They tell whether you are a grade customer or a B grade customer. It can be based on your credit history or past loan payment performance. So that is the grade column. And what I'm doing is I'm grouping by grade and getting count of values in each grade. So how many accounts are there in each grade? That's what I'm doing. And again, if you're running Pandas, it's the same command again. right? So this will give you the different grades that are available. There's a grade, B grade. There are multiple grade of account, and in each account, each grade, how many accounts are there. So in this case, the A grade has 38,011 account. The B grade has 35,861 accounts. Basically, most of the customer on A and B grade and the C grade as well, right? Typically you want to give loan to people who are more ability to pay back, so you typically give more loans to the higher grade customer, right? So this is one of the function, right? Now what I'm doing is that one function I'm setting. The second function, I am just doing the same part. I am just doing a count of grade, and I am dividing it by the total count. So basically I am taking the percentage of loans in each grade. That's what I'm doing. So the same function as top divide by the total grade. So this will give me, okay, A grade in terms of percentage, A grade has 30% account, B grade has 40% account, or whatever it is, right? It will give that output. So if you see the output, it says most 29% of my customers are in A grade account, 27% of my customers are B grade account, and 24% in C grade account. Like pretty similar to Pandas command, but you're getting the output. Now I want to combine this data frame, the percentage data frame, and then the count data frame. These two will give me separate data frames into a single data frame. If you are using Pandas, you will do a pandas.concat, pd.concat. But instead of that, you are just doing a ks.concat. And if you see this command, it's pretty similar to what we gave on the top. This is for the count, and the second data frame is basically the percentage. And I'm basically concatenating in the axis one, which is the columns, right? And I'm assigning it to an ld underscore temp data frame. So basically I've get a new data frame over here, and let me run this also. I'll get a new data frame which will have two columns, which will have three columns rather, which will have the grade of the account, which will have the count of the account, which will have the percentage. If you see here, all the three has come into play over here, right? Basically I have to maybe give head of say 8, so that I see all the value as output. All right, so now you can basically like see, like, okay, all the grades are there. Now I have different values over here, percentage. So now I have a data frame. Now what happens, like if you see, Spark does not have a concept called indexing. But Pandas has a concept called indexing. If you want to create an index column so that you can easily join and group by, you can do that in Pandas. But Koalas also has concept called indexing. That's why you're seeing grade is an index column, and these two are basically column that is basically indexed with grade. All right, and if you don't want to have that index column, you just want to have a regular column, you just say like reset index, similar to your Pandas. Right now, one of the shortcoming of Pandas is it does not have a SQL like syntax. So you need to basically, Spark is pretty good. It has Spark SQL. You can run a SQL command. It makes your code more interpretable, as well as like it's easy to code, because a lot of people are aware with SQL, and they don't have to go to low level functions unless until required. Right now, one good thing about Koalas is you can use the SQL syntax. So basically, you can, and this is not in Pandas, right? But it is more convenient because a lot of data analyst or even data engineer or machine learning engineer are aware of SQL. So in this case, what I'm doing is I'm doing KS, which is my Koalas import that I did, .sql, and I'm selecting from the table ld underscore temp that I created, and I'm selecting only where the grade count is greater than 300. So if you see over here, I'm selecting only grade count which is 300. So you will not get the account which has 101 and everything. Right, I can just fire regular SQL. The one good thing is Spark, as Spark SQL and Spark data frame, all this will get converted into a similar execution plan. So Spark will take care of forming the DAG for you. Now this Koalas is not a lazy loading framework like Spark, so you will see the output as soon as you execute it. In case of Spark, you have to give the action command to see the output. Now I have a separate video on Spark transformation and actions. So if you want to see that video, you can click the link on the top and watch it, which talks about Spark data frame function, like actions and transformation. Now, one thing to note before I go further is this package is not still yeah, in a major release. It is still in beta release. So around like 60 to 70% of the pandas function are available. So you will not have all the pandas function available. But over the time, this looks pretty promising and makes your life pretty easy as well. Right now, if I want to sort based on the index, if you see the output over here on top, you are basically getting not in order: A grade, B grade, and C grade. So this is the index column. So what I can do a sort based on index, or I can do a sort based on value. Before I go there, if you see the greater than 300, you are not getting the null column, and the 100 the account that had grade count 100, you are getting the remaining column. So basically SQL is also working as expected. Now if I do a sort index, then it will sort based on the index column. So if you see, basically earlier it was jumbled. Now you will get sorting based on the index column, which is A to G account, right? So it'll come in that particular order. If you see here, is sort based on grade. It's coming in that order. Now there are two null values, and that's because when you are doing with Koalas, it also creates a null value even though there's no data in that. I will drop the null value as we go further. Right now, you can sort by a particular column as well. So in this case, I'm just doing an sort values by grade percentage. I want to see like which grade has the maximum percentage. I can do that as well. And as I mentioned, this is the same syntax with pandas. I'm just repeating to make sure I tell you the difference between what exists in pandas, what does not exist in pandas. Right now, the other, if you see here, now it's sorted by grade percentage to 0. So the maximum grade loans are in A, maximum loans are in A grade, then B grade, then C grade. Right now, one thing I can do is I can apply any Python function to Koalas, right? That makes it's even more easy, because Python has some strong libraries like NumPy, and I want to use the function. I can do that. So in this case, I'm just going to import the NumPy package. And then what I'm doing is I'm taking the Koalas data frame, which is LDTemp, and then basically I'm applying a sum function. So what it will do is it will take, we have two column, grade percentage and grade count. It will just sum and show the output. So apply is again a pandas function where I can regularly apply any custom function or use a lambda function. So that's what I'm doing over here. So you can see basically it's to showing me sum of grade count, and sum of percentage is always 1. We just did a percentage column, which is always 1. Right, you can also drop the null values. You see the top, there are null values and everything. You can just do like a drop NA of the data frame similar to pandas. I am assigning it back to LDTemp so that I get the data frame now without the null columns. Let me display the output now, and when I display the output, you are going to see the null columns are no longer going to be there. Right now it's not there. Now only you have like A to G grade loans. I can also apply lambda function. So if you see over here, what I'm doing is I'm taking the temp object, I'm applying, I am taking each row and within each column I'm multiplying it by 2. So if you see the output, you see on the top, you can see it's 387, 5962, 35. And what I'm doing each of this value and multiplying by 2. So you can see in both the cases, the value is doubled now, even for the grade percentage and grade count. I can do that, or I can create a function as well. So if you see over here, what I'm doing is I'm creating a custom function to multiply, and I'm telling my output is NumPy array of float 64, and I am returning that input value multiplied by 2. So I can create custom function. When I want to reuse the function multiple times, I may create this custom function and I may use it. So now this is the same thing as what we saw. So now you can see basically the output will be more like multiplied. Right now, another good aspect of Koalas when compared to Spark is the plotting function is built in. Now, earlier when we were using Spark, right, when you want to plot or use some of the Python libraries, matplotlib, you have to do two pandas. So get the Spark data frame into your driver node, converting to pandas, and then use the Python libraries. But in this case, what I can do is I can just say like LDTemp, which is my Koalas data frame. I'm telling the plot function similar to pandas.plot, and I'm telling give a bar chart for me, and it's going to like just run it and give a bar chart. Now, if you want to convert a Koalas data frame into Pandas data frame or into Spark data frame, there are functions available like from Pandas is basically converting a Pandas data frame into Koalas. From Spark data frame, you have functions for everything. So you can move the data frame from one function to other. If you want to complement additional packages that are available part of Spark or Python, you can do that as well. So now if you see, it's just showing the bar chart for it. Now the grade percentage is not shown because percentage is very less when it compared to the grade, so it's almost negligible, so it's not showing it. But to give you an idea, it can do bar chart, it can do line chart, histograms, scatter plots, all the plots are available. So I just want to take this video to quickly introduce you to Koalas, which looks promising, which can provide Pandas like API, which can significantly reduce the learning curve for people coming from Python into Spark. So that's about it. Thank you very much.